with DevOps is why are we doing it, and then also what is it, right? Those are two of the key questions. So what I'm going to do is I'm going to dive into some of the books that I've written recently, and we'll cover some of the answers to those questions in the book. So the first one I'm going to start with is the book Python for DevOps. And so Python for DevOps was published 2019, and the authors really have a ton of experience. I think maybe combined like 100 years experience with DevOps, and I think that these authors I think give a really good summary. And if we go through here and we scroll down, like what does DevOps mean to the authors? This is a good place to explore what it is. So one answer here is it's a two-way collaboration between the development and the operations team. So this is a really critical thing to bring up, is that DevOps really is the ability to synthesize the communication between software engineers and operations. For a long time, and I've spent a lot of my career like this, people did their siloed role. Like there would be the operations team and there would be the development team. And really the future is that those two roles have actually merged. And I think most organizations realize that there is really a combined synergy in having one person do both roles. No, there are exceptions and people do, different things, but in general, it's completely, I think, within scope to say that everybody should be able to do DevOps that's a software engineer. Another thing is right here is the turnaround of ops tasks in minutes to hours, not days to weeks. And this is another really critical one that I've seen a lot in my career. I remember I was working at a company that did the metaverse, right? This is a big deal now, but I worked at a company that was way back in the day doing metaverse things. And one of the issues we had was that things would take a week to deploy. And I think originally there's probably a good reason for that, because there was a C++ game engine and people wanted to be very, careful about deploying things that were revenue focused. But it ultimately caused big issues with developing new products. And so this is also the future, is that I would say this is one of the top KPIs for an organization, is are you able to deploy your software within minutes, not within weeks or within days? If you cannot, then I would say you're not doing DevOps. You need to reevaluate what you're doing in your organization. And if your boss or someone in your company is upset when you say that, give them my email and I'm happy to talk to them. Another answer here is strong involvement from developers. Otherwise, it's the developers versus the operations team. So I think this is really a sub point underneath the two-way collaboration between development and operations, is that there needs to be, basically either the same person is doing both roles, or a uniformed team combined of the developers and operations. There cannot be siloed teams. Another one that I think is also a little bit subtle in some sense, I'll just scroll through as we get through these, is that operations people need to actually have programming abilities. So I think this is another one that is really easy to kind of dismiss and say, oh no, the operations people don't need to know a little bit of Bash or Python. Well, they do. And I think this is really one of the issues, is that it is important to know Bash. It is important to know Python. And especially as the roles merge, it's going to make everybody more productive on the team. And in terms of another highlight here is developers need operational skills. Their operational responsibilities don't end with writing the code, but with deploying the system and monitoring it. So this is a really key point as well. And I found this out in my career, is that when I was CTO of a company with 100 plus employees, I heard this all the time. One of the things I heard was, that's DevOps job. And I have to admit, it always kind of raised my blood pressure a little bit when someone said that. My response was, it's everybody's job to do DevOps, because DevOps is a behavior. It's a little bit like saying, physical fitness is the athlete's job or something. Like, no, if you don't walk every day or do some kind of exercise, you're harming your body. Like, it doesn't make sense to say that it's somebody else's job to do an essential component of your job. And another component here is automation, right? This is, I think, my entire career in Los Angeles, the Bay Area, New Zealand, Atlanta, wherever I traveled all over the world. When I did jobs, basically what I did, if I had to summarize it in one word, would be automation. And that's at the heart of automation. You have to automate every single thing you do: the infrastructure, the continuous integration, the continuous delivery, the monitoring. All of these things, the auto scaling, have to be automated. If you don't have automation throughout your entire ecosystem, you're not doing DevOps. You're doing something else. And another key component here for DevOps is that it's self-service for developers, right? So, and what this really means is that you have infrastructure as code and continuous delivery set up. If you don't have those things set up, then it's not going to be self-service for the developer. And really, you're putting your entire organization in a bad spot if it's not set up in a way that the developers can always do a self-service deploy. Now, it doesn't mean that it has to automatically go to production. A self-service deploy could go to a staging environment, and then it could be, manually switched over to production. But it's the concept that the code is always deployable. Really, this is the key win. Also, DevOps has, continuous integration, continuous delivery pipelines. Another one is this concept of bidirectional everything between, the development and operational team, right? Which is kind of what we already talked about. Constant collaboration. This is also, I think, a key one here. This constant collaboration is that as you're deploying the software and automating it, you have to actually have everybody involved in it, or else it's not going to be successful. Like the QA team, the development team, the product managers, everybody has to be constantly looking at, oh, look, the deploy worked. Yeah, oh, it didn't work. Here's the bug, right? It's a group effort. If it isn't automated, it's broken, right? Here's another one. Cultural. The hierarchy is not as important as a process. This is actually an interesting one that many people probably have experienced themselves, is that I call this, the hippo-driven development. And what the hippo-driven development means is the highest paid person's opinion. So it could be the CEO, it could be a big shot at the company. They come in and say, I want this feature, I want this deployed today, or whatever. That's actually basically like a poison for DevOps, because you shouldn't have some person who's powerful just coming in and just blowing up the entire system. It doesn't mean that they don't have an important request and it can go into a queue, but it cannot trump the process, or else you have chaos. And this is, unfortunately, many people that have no experience in the software industry, this is what they gravitate to, and they like pound the table. I want this. Like, sorry, you don't get it. I think that's unfortunately what you have to say to those people. The other one is microservice versus monolithic here, right? Is that I think we're seeing this trend of people going towards the microservice approach, and especially if you look at what AWS talks about in terms of their definition of DevOps, it's a microservice approach. And continuous delivery and deployment system is at the heart and soul, right? It really is. If you can't deploy software constantly, you're not doing DevOps. I mean, this is really the one of the other truth serums is, are you continuously deploying your software? If you're not doing DevOps. You're doing something else. And then a couple other things here is that there are no superheroes. And I think this is another big one that is a toxic brew at an organization, is you have these superhero developers who are, working till 4 a.m. and they're doing all these magical things. And I have seen this over decades, and it never ever works out. It never works out. Now, if it's a solo project like a mobile app that one person develops, it actually could work out well. In a team, this is just a cancer. And so this again is the hierarchy versus the process, because being a superhero is a form of hierarchy. It's a form of power. So if you have this as well, it really is an issue to address in your organization. So that's again kind of the what is DevOps and kind of some of the answers behind it. The other thing that I'll bring up is, if I shift over into practical MLOps, one of the things that I'll talk about here is, in terms of MLOps, is that you see MLOps as well heavily involved in machine learning operations. So machine learning operations is one of the hottest things right now. I'm sure everybody's talked about MLOps. Everybody's talking about MLOps. And one of the surprising things, I think, especially to people in the academic world, which I have a foot in, right? I teach data science at Duke. I teach data science at other universities, as well as MLOps, is that world, data science, has almost no experience with DevOps. If you said to somebody that is creating models, at a university, like a professor there, they don't know what DevOps is. I mean, maybe 1 in 100 know what DevOps is. And so this also shows that even if you're not maybe directly doing MLOps, that you're an extremely valuable resource, because DevOps. And here's why. At the root of ML engineering is DevOps. And if you don't have DevOps, you cannot do MLOps. And I'm also, if someone disagrees with me, you can get my email. I'm happy to talk to a boss about this, because it's non sequitur to say that you can do MLOps without DevOps, because if you can't continuously deploy your software, how could you possibly continuously deploy a machine learning model? It doesn't even make sense. You're missing all of the subcomponents. So that's another really critical thing to consider when you're dealing with DevOps. And then one other thing I'll mention here, I'm going to shift into the next book, which is Developing on AWS, and so which is going to come out pretty soon. A little bit of it is not already on O'Reilly, but in this book as well, I talk about the kind of the root of DevOps, like what is its origin, and its origin really is from the Japanese automobile industry and the culture of Japan, where there's this concept of the plan, do, check, act life cycle. And this is at the heart and soul of really all continuous improvement systems. And it's the scientific method, but translated into more of a engineering focus. And so the way this works is you plan something. So you could say, I'm going to develop a web service. And so you've identified the problem. We want to build a web service that talks to the database and retrieves back, the highest paying customers in our organization, right? As an example. You then do it. So you test out the solution. So you build a microservice. You have, maybe continuous integration, or you have to have continuous integration, continuous delivery. You kind of check that out, make sure that it deploys successfully in a staging environment. You analyze it. Hey, it looks good. All the metrics are there. Our monitoring's there. Okay, let's go ahead and deploy into production. Once it's deployed and you implement it, then you take a look at it again. And if there's a bug or there's some new feature you need to add, you do the same life cycle again. So this is really the heart and soul of DevOps, is this concept of plan, do, act life cycle. Now, the other one that is a very important component of DevOps that a lot of people don't really talk about, but is really critical skill to learn, is this concept of 5 whys. And 5 whys also is heavily, influenced by as part of the Kaizen culture of continuous improvement. And here's actually a real world example of something that happened in my career. I was working at a big data company. I was head of engineering, and I was pretty new to organization, so I didn't know all of the different things that had occurred. And we had these random server crashes, and they were really severe because they were causing significant downtime, and customers were upset that servers were crashing, they couldn't get their log data. And so this is really the process that we used to debug it. So first was we posed a question, right? 5 different questions. Why are the servers crashing, right? And so the next answer is I don't know. There's no log files on the server. So then the natural thing to go through is to say, well, why? Why don't we have log files on our servers? That seems pretty important. Well, those servers use ephemeral storage and they have no swap partition, right? So ephemeral storage on AWS means that if they reboot, it's gone. And in addition, the machines were configured to not have swap. Swap is a partition that enables you to page out memory to disk if the machine is consuming too much memory. And then the answer to that was, well, the next question is, why are they using ephemeral storage without swap? That seems risky. Well, the answer was there was a DevOps specialist who didn't work there anymore that used to work at a top company, and they said don't use swap because the top companies don't use swap. And then they also said that ephemeral storage is cheaper, so we're going to use that. So then the next question is, okay, well, what happens if we just enable the swap partition and then we do EBS storage, which is block storage, and then what about that? Okay, now we see something, right? Now it took 4 layers down to go ahead and see what it is. It's a kernel panic, and it's an out of memory error in the crash logs. Okay, well, let's ask the 5th question. What's causing the out of memory error? Here we go. The root cause was there's a Java application, which was the search engine, that had over allocation of memory. So the server was allocated more memory than the machine actually had. What happens then is that when the Linux kernel realizes that a process is out of control, it'll just kill it. So in some sense, this works out okay. In some scenarios is that, Java servers accidentally misconfigured, the Linux kernel, knows that it's consuming too much memory, just kills it and restarts. So it's not optimal, but it's probably a reasonable, machine for a while under that approach. But because we also had a supervisor process monitoring the process that also restarted it automatically, there's a race condition, and they just the Linux kernel stopped it, and then the supervisor started it, and they just went to a race until finally the machine crashed. And because we didn't have any way of storing the crash logs, we have no idea what was happening. So this technique is maybe one of the most valuable techniques for troubleshooting that you could use, and it is really a part of DevOps. And in terms of DevOps best practices here, I would say the core, right, of a DevOps best practice is you have to have, continuous integration when you're building something, right? So you need to have a build system. You need to have your test code. You need to merge your code. It needs to be automatically triggered on the build. You have development environment. It goes through, puts it into the repo, and then you can pull it into any other development environment. So that this means that everybody in the team always has good code. If you don't have something like this, then every person on the team could have different versions of the code, and the code could be in different states, right? Some code is working, some code is not working. The build server ensures that the code is always working. And then if we go down here and we talk a little bit about, well, continuous delivery, right? This takes it to the next step. The idea here is that you're working in a local environment. You go ahead and you push your code to infrastructure with infrastructure as code. So like code that defines, let's say, storage devices, networking devices, web servers. You push all that into a single repo. That triggers the build. That code merges back. And then from there, the build system will actually create and manage the infrastructure itself. So the build system not only does a test of the code, but it also uses the infrastructure as code to actually deploy that to another environment. And this continuous delivery workflow is Kaizen, right? Which is continuous improvement, right? And so this is really the heart and soul of what DevOps is. And you see the artifact is that you're able to automatically deploy your code. And if we scroll down here, a few things to talk about in terms of infrastructure as code is that in terms of the process, the first time you deploy, it could provision the infrastructure, right? It could provision, let's say, a load balancer with 3 different web servers associated with it, and networking and talking to a database, right? But the second time, it will make a change. If there's no change to be made, and this is called idempotent, right? So it means that every time you do a deployment, it always keeps things in the same state. Either it creates things, either it keeps things the same, or it mutates it if you make a small change to production. And so you don't ever have to worry about running the infrastructure changes, because they're always going to keep things in the same state. And this is a really critical component of continuous delivery, and it's made possible by infrastructure as code. The other advantage of using infrastructure as code is that you can clean up your assets, right? So you can completely go through and clean up an experiment or a staging environment. And so this is really, again, at the heart and soul of what infrastructure as code is. And then the other thing to mention about DevOps that's critical is that it is a monitoring and logging is something that you must do. And I think of it as data science for software systems. So you're able to take all of the metrics, the logging, the application logs, the machine logs, the metrics, the CPU, memory, disk I/O, and you put this into a dashboard. And so you actually do data science. It really is data science, right? We've been doing data science on systems for quite some time. Many people in operations didn't realize it. There wasn't some fancy term for it, but we are actually taking logged. We're looking at statistical analysis. For example, if there's an event that occurs that's, more than, 3 standard deviations away from the median, like a response time, there's something weird going on. And I've seen this before, like a server is misconfigured. So you can use traditional statistics to actually look at, what's happening and fix it. The other thing that also comes up with DevOps is that it's a behavior. And so this is, I think, a really important component to really talk about here, is that DevOps is not just a job title, and there's some debate whether it should be a job title or not. I say it should not be a job title. I think it's just something that you're supposed to do as a software engineer, is that it's basically implicit to a well-run software engineering process. And so you have a ticket. The ticket is identifying either a feature, a bug, and you're then going to convert a request from a human into source code. Once that source code gets created, then there's a pull request where other humans take a look at it. They put some comments about what's happening. They merge this into GitHub or whatever source control management system you have. You then trigger the build. It goes through, it builds the code out, and then there's an optional, maybe human involved as a resource manager. It then goes into a production system. There's an operational dashboard, and that operational dashboard also tells other humans and machines what the status of the production system is. Those messages could go to, let's say, a chat server that gets deployed, and there's a versioned artifacts that you can take a look at. So it's a constant communication process when you're dealing with DevOps. And a couple other things we'll mention here is that from a security standpoint, that's another thing that DevOps is helping you with, is that when you do have automation, it gives you the ability to be secure. If you don't have automation, security really isn't possible either, or it's very difficult, because in the case of modern systems, there's so many different moving pieces. The only possible way to constantly maintain security is to have automation. And so here's a good example of security here, where we have AWS security group firewall rules. They're blocking inbound ports. The data is encrypted at rest. There's encrypted in transit to S3. The automation system is deploying all this stuff. You have CloudTrail or some other, whatever cloud you're on, monitoring system. You have two-factor authentication. You have the security policies, in this case for AWS, using the principle of least privilege. So the entire thing requires automation. And I think this is another thing that companies that are taking a lot of chances in terms of security are not aware of, is that if you don't have DevOps or automation, security is almost impossible. Because if you change something that's, let's say you accidentally or intentionally make everything secure once, how are you sure that in a week someone doesn't change something and now it's insecure? And that's really the heart and soul of why DevOps and security are tightly coupled. And if we go down here and we talk a little bit more about some of the things that like our use cases for DevOps and like real world scenarios, I think one of the classic continuous delivery examples that I like to show people is a static website. And so this is a good example. Hugo is a static website technology that I use, and it's pretty straightforward to set it up. You have source code, you demo it on a local server, maybe AWS Cloud9, one of my favorite development environments. You push it to GitHub, it triggers a build, and then your build server goes through and it makes infrastructure changes, it builds the site, it syncs the data to S3. S3 then pushes a copy to the CDN, which is CloudFront. You have a Route 53, which handles the DNS, and you have a global scale website, like Wall Street Journal, New York Times scale website, just with this kind of a process. And that's really the power of both cloud computing and also DevOps. And another flavor I think to be aware of here is this concept of flavored, containerized flavored DevOps. And I think this is really the future for right now until some other thing comes up in the next couple of years. But it does seem like if you're not using containers, you're really missing out on a lot of things. And the reason why is that it makes things idempotent and reproducible in deployment. And so with a container, you've got the runtime associated with your project as well as the source code itself. And it also makes the deployment very, very easy. So in this case, this is AWS, right? You have the build system, the infrastructure as code, the source code, the Docker file, all this stuff is in GitHub, right? So you can look at everything. It's pushed to a container registry, in this case, Amazon ECR, and then cloud environments will auto deploy. So really this simplifies dramatically the process of doing deployment. And then finally, I think a few critical thinking discussions are, what's your definition of DevOps and how can you use it to enhance your organization? So those are some of the things to think about. And then finally, a couple other things I'll talk about in the Enterprise MLOps book is that, closely related to this is this idea of not reinventing the wheel. And I think that's another, key component of DevOps. And here's an example of that is that especially in the MLOps space, you see this, but you also see this in regular software engineering, is that there'll be a brilliant engineer who builds like a custom solution and it maybe even doesn't use DevOps or something like that. They are so smart that they get paid 10 times their salary and they get hired by $1 trillion company. And then guess what happens? 3 months later, even though the system is really good, it breaks because no one knows how to fix it because that person left. And what happens is it gets replaced by a proprietary system. Now the organization has to retrain people on the new system, and a new system delivers superior results. So really, this is another component of, remember the no superhero theorem that we talked about earlier, is that you don't want to do superhero solutions with DevOps. So those are some of the key ideas in terms of the theory behind DevOps. And if we go back here and we look at this, right, we answered the why successfully, and we answered the what successfully. And I'll just sketch out here, some of the things that I think are a good best practice. Again, you have at the heart and soul is the build system, right? This is really, what we care about is the build system is where everything that is good really occurs. And the build system will communicate with production, right? So this talks to the production environment, and it also talks to your source control, right? And in this case, the source control. And that's kind of the most essential form of describing in terms of the minimalist, DevOps components and capabilities. And there's features below these, right? There's subcomponents of this, but at its heart and soul, you've got the environment, you've got the build system, you have the source code. Those are really the things to care about. And I think one thing to really bring up here is that, as I mentioned before, containers, I think, are becoming a huge part of the story. And one of the things that is really important is to use environments that make it easy to build containers. And in particular, I would say that what we're seeing is this concept of a cloud-based dev. So we'll call this cloud dev environment. Here we go. And this, I think, is the future as well. If you want to get a shortcut on, the top new technologies that are happening, is why develop on your laptop or some workstation when you can develop in the identical environment that the code is being deployed into? And so a good example of this is Cloud9, right? Or another example of this is GitHub Codespaces. These are two really good tools that we're seeing people use to supercharge their ability to build out code. And so this will be a good segue to just show you very quickly both of those tools and show you some of the bells and whistles of those. So to start with, we'll do the easy one, which is GitHub Codespaces. And I'm going to go over to my account here, and I'm going to create a new repo real quick. And we'll just call this, DevOps 2022. And we'll say this is a repo for DevOps. And I typically just put README file, git ignore for Python. Those are kind of the essentials. And we'll create that repo. And once you have a repo, you don't have to do it this way, but typically I create a repo. You can then go over to code here, and you can actually create a code space inside of your environment. If I want to do a custom one, right, I could look at machines that are even up to 32 core GPUs, but I'm just going to go ahead and create a code space here. And I'll show you some of the reasons why this is so important. Okay, so when you start out with in this code space, it's got really everything you need to build containers, to do microservice development. All of these features are available, code highlighting, and it's most likely either the same or close to the same environment that you're going to actually work with in terms of a production environment. So this is a huge win, and it allows everybody in your team as well, right? If we know that DevOps is a team-based strategy, it allows everybody to be on the same space. So if I type in, for example, Python, right, I know everybody in my team has Python 3.10.4. Likewise, if I want to install Docker, well, guess what? We already have Docker installed right on my machine, right? Or Docker image ls, right? We know that Docker is already on my machine. Everything's all set up for me, including syntax highlighting, code highlighting, preview for web browser. So if I build a web service inside of here and I wanted to do a preview, it also can do preview right inside. So really, really powerful environment. One tip I'll say here is that typically what I do is I always edit my bash RC and I create a virtual environment. So this is probably the big takeaway: create a virtual environment, tilde.venv like that. And then go ahead and go to your bash RC, which is your bash shell config file, and go through here and put at the very bottom this Python virtual environment. And this just solves a lot of problems that come up in the real world with Python Activate, because you don't have to worry anymore that your environment is basically bulletproofed from weird things, right? And now we know that we're using that virtual environment, and if I type in which Python, right? So that's kind of my basics for Python. Now let's talk about the other one, AWS, right? Is a similar one that mimic the